Welcome to the deep dive. We take that stack of sources you send us, pull out the key knowledge, and, well, hopefully give you the fast track to really understanding what's going on. Our focus today is pretty huge. We're doing a deep dive into the recent quality control crises over at Ford. We'll be dissecting the engineering side of things behind their massive recall figures in 2025. And when we say massive, we really mean it. It's almost statistically strange. The sources you sent paint a picture that Ford hasn't just had a rough year. They've actually broken records. First 6 months of 2025. Highest number of recalls ever for the company. And then they really ramped it up, accounting for something like 60% of all vehicle recalls from all car companies in Q3 2025 alone. It's breathtaking, really.
It really makes you pause, doesn't it? Just the sheer volume. That 60% number, I mean, what that actually translates to is, well, Q3 saw over 5 million vehicles recalled just by Ford.
5 million.
5 million. And if you put that next to the next closest competitor, Stellantis, they had about 802,000 vehicles affected in Q3.
It's not even in the same league. It points to a crisis of scale.
Yeah.
It really demands a serious look into their whole quality assurance process.
Yeah, it absolutely feels systemic when you see numbers like that. But okay, today we aren't going to try and tackle all 5 million vehicles. That's just too much. We're focusing on 2 specific high-profile recalls, and they really showcase 2 wildly different ways things can go wrong inside a company like Ford. We're zeroing in on the heavy-duty workhorse, the F-Series Super Duty pickup, and then the iconic muscle car, the Mustang. Just these 2 recalls together, they account for nearly 625,000 vehicles. Okay, so let's unpack this. Starting with the F-Series, these are the big ones, right? The 2020 through 2022 F-250, F-350, and F-450 Super Duty models. These trucks, they're built for serious work towing, hauling, tricky maneuvers, which is exactly why they lean so heavily on these advanced sensor systems.
And what's interesting here, I think, is that this specific failure, it's kind of a perfect snapshot of modern car vulnerability. It involved the 360 view camera system and the electronic brain behind it, the image processing module. This is really critical tech, especially for trucks this size.
Right. Okay, so for you listening, why is that module so key? What's it actually doing when you shift into reverse?
Well, think of it like the ultimate video director for your truck. It takes feeds from cameras all around the vehicle, stitches them together, and it has to dynamically adjust those feeds based on the light. So if you're trying to maneuver a huge trailer, you absolutely rely on that 360 view to do it safely in tight spots. The problem here, it was actually tracked back to just a few owner questionnaires initially. Drivers were saying that when they were backing up into a dark area like a dimly lit garage or maybe a loading dock, the rear view camera image was just unusable.
Unusable how? Like totally black?
Either totally dark, yeah, or sometimes completely washed out, too bright,
Yeah.
just not showing what was actually there.
So it wasn't like a wire broke or the camera lens cracked. It was the electronics, the software failing to handle a real-world situation. I can picture it. Backing your Super Duty out of a bright, sunny construction site and maybe turning into a shaded alleyway. That's a huge jump in light levels.
Precisely. That's a classic high dynamic range, or HDR, challenge for any camera system, especially the software processing it. Ford looked into it and, yep, they found the system was applying an incorrect light balance algorithm. Basically, in those mixed lighting conditions, bright to dark to bright, the display would just swing wildly. It rendered the screen either way too bright, so you lose all the detail in the highlights, or way too dark, looking almost black.
That is a serious safety issue. I mean, especially since these vehicles are built specifically to be safe under heavy load, under stress. If you can't see properly while you're trying to reverse and hook up a multi-ton trailer, well, that could lead to some pretty severe consequences. And it all came down to an algorithm glitch, not a physical part failing.
That's the irony of modern cars, isn't it?
Mm-hmm.
The good news, though, is because it is just software, a software oversight, the fix is actually incredibly simple for the owners.
Okay.
The remedy is just a digital software update for that image processing module.
Mm-hmm.
Owners take the truck to a Ford or Lincoln dealer, they plug it in, update the code, and it's done free of charge. It's a classic case where ideally this could have been an over-the-air update, but for this one, it does need that dealership visit. Still relatively painless.
Okay, now let's pivot completely. We're shifting gears here. We're going from a sophisticated software glitch on a brand new massive truck fixed with a simple patch to something much more fundamental, a material corrosion issue on a legendary muscle car. We're talking about the Mustang. This particular recall hits models from 2015 through 2017. That's the 6th generation, the S550 platform, for those keeping track. And it's really important to stress right away, Newer Mustangs, not at risk here. The part involved, the seatbelt anchor pretensioner assembly, was thankfully taken out of production after 2017.
Right. And this Mustang failure, digging into this one is fascinating because it really touches on environmental physics, believe it or not. The core component that's failing is the seatbelt anchor pretensioner assembly cable. The source materials are pretty clear. This cable, a vital safety bit, was eroding. It was getting weak, maybe even totally ineffective over time.
Okay, before we get into why it was eroding, maybe let's quickly explain the pretensioner itself. For anyone listening who isn't deep into auto engineering, why is this specific assembly so critical? What does it do?
That's a really good question. Most people just think about the seatbelt webbing itself, right?
Yeah.
But the pretensioner, that's the first responder in a crash. Its job is instant. The second a collision is detected, the pretensioner mechanism, often it uses the tiny pyrotechnic charge, like a small explosive it fires, and that instantly tightens the seatbelt, pulls the occupant firmly back into the seat, gets rid of any slack before the main airbag even deploys. So if that cable is corroded, weakened, the pretensioner might not activate correctly. Or maybe it activates but then fails under the force.
Yeah.
Either way, it severely compromises the whole safety system.
So yeah, definitely a life or death component. And this is where the investigation gets really interesting, as you said, connecting it to external factors. The erosion wasn't caused by some fluid leaking inside the car's systems. The sources point directly at exposure to corrosive stuff, specifically salt water.
Correct. And that immediately tells you which areas are likely most affected, right? Drivers in snowy, cold climates. Places that use a lot of salt or brine on the roads in winter.
Okay.
That salty slush, it gets tracked into the car on people's wet shoes. Standard stuff.
But hang on, this is a Mustang, a Cooper convertible. Are we saying Ford is liable just because someone tracked in salty slush? Isn't that just environmental wear and tear? That's exactly the crucial question the investigators had to nail down. And what they found was, no, there wasn't a direct seal failure, like water leaking into the pretensioner assembly casing itself.
Yeah.
That wasn't it. But they noticed a key design detail, maybe even a flaw, you could argue. The carpeting right around the pretensioner assembly. It came into direct physical contact with the cable housing.
The carpet itself was touching it.
Yeah. And this is where, as I mentioned, the physics comes in, the science of wicking. So driver gets in, boots covered in wet, salty snowmelt. That water saturates the carpet nearby. Then that salt-heavy water wicks, soaks up along the carpet fibers. And because the carpet touches the cable housing,
Oh, wow.
it transfers that corrosive liquid right onto the cable area. Over time, years maybe, of this slow, repetitive cycle of getting wet, drying, getting wet again.
Yeah.
It creates this perfect little corrosive environment right where that critical safety cable sits.
Yeah.
And eventually, potentially, failure.
That's a really profound design oversight, isn't it? It's not a failure of the safety part itself initially, but a failure of how an adjacent part, the carpet layout, interacts with it. It failed to protect it from a known environmental hazard in like half the country.
Absolutely.
Mm-hmm.
It really highlights a potential blind spot in durability testing, specifically for these regional environmental interactions. Did they test for 5 years of Canadian winter salt slush wicking up the carpet fibers in the lab? Maybe not to this extent. It just proves engineers have to think about how even basic materials like carpet might act as a pathway for corrosive stuff brought in by the occupants. This wasn't some high-tech sensor fail. It was basic material interaction.
So the fix for Mustang owners then sounds like it's got to be more involved than the F-Series software patch.
Oh, much more involved. It requires actual physical work. The procedure involves removing the carpet immediately surrounding the pretensioner assembly, basically getting rid of that wicking path. Then after that, they have to do a full inspection of the assembly itself. If they see any corrosion, any damage, the whole component gets replaced, all free of charge, of course. But yeah, much more hands-on, much more time-consuming than just plugging in a laptop.
Okay, so let's try and synthesize this. Pull it together. We've looked at two dramatically different challenges here, both adding to Ford's really staggering 2025 recall numbers. You've got the F-Series, failure rooted in a complex software algorithm for a cutting-edge camera system, high-tech. Then the Mustang, failure rooted in basic material corrosion, enabled by an almost mundane design choice about how the carpet meets a safety part, interacting with the external environment. Low-tech, almost.
Right. And if you connect that to the bigger picture, the 5 million recalls, it really suggests Ford's quality control problems aren't just stuck in one department. It's not purely a software validation issue, nor is it just a problem with, say, old-school material durability. It seems to cut across the whole spectrum of engineering complexity. From validating sophisticated sensor fusion algorithms all the way down to making sure carpet fibers don't end up corroding a pyrotechnic safety device when exposed to road salt. And that breadth, I think, is what makes the overall recall numbers so alarming. As we mentioned earlier, a lot of those other 5 million vehicles recalled in Q3 also involved camera software issues, hitting various other models beyond the Super Duty.
So the F-Series camera wasn't just a one-off.
Doesn't look like it. It's the systems, the validation processes themselves, might lack the rigor needed to catch problems with both these next-gen technologies and the long-term durability of how components are packaged together in the real world.
And it's worth remembering the business context here, too. While the Super Duty models recalled are a few years old, 2020 to 2022, the F-Series line itself is still Ford's absolute bread and butter. It's critical. Their Q3 F-Series sales were actually up 4.7%. They sold over 620,000 F-Series trucks year to date. So Ford is wrestling with these major quality headaches while still trying to pump out huge volumes and meet massive market demand for its most valuable product.
That's a tough spot to be in.
It really feels like this constant push for more tech, more features, more connectivity, faster development cycles. Maybe it's putting intense pressure on the kind of deep, long-term durability and safety testing that used to be standard, even for something as simple as how you install a piece of carpet.
That pressure definitely seems visible in the data we're seeing. And just think about the contrast in the fixes we discussed. One problem needs a technician with a laptop to update code, maybe takes an hour. The other needs a technician to physically rip out interior trim, inspect for rust, potentially replace a safety-critical pyrotechnic device. Much longer, much messier. The solutions are as different as the problems, which just underscores how wide a net Ford needs to cast to really get these QC challenges under control.
Which does raise a pretty important question as we wrap up.
It really does. And maybe let's leave you, the listener, with this final thought, going back to that very specific Mustang corrosion issue. We saw how the design of the carpeting basically acted as the pathway, the fatal conduit, for environmental factors that caused a critical safety part to fail. It makes you wonder, doesn't it? What other seemingly minor, maybe innocuous design choices are out there? Where a plastic trim piece happens to sit, or where a sealant bead ends, or maybe how an electrical wiring harness is routed near a drain hole. Could these little things be creating unexpected long-term vulnerabilities in vehicles, especially when they're used day in, day out in specific challenging regional climates, like the salt belt? Are manufacturers truly stress testing for 5 or 10 years of daily saltwater wicking in their labs? Or are they just discovering these things out in the field years later? It's a big question.
That is a fantastic point. The driver battling winter in Michigan might be uncovering flaws that the sunny California test track simply never would. So, you now have the key insights on two very different failure mechanisms contributing to Ford's record-breaking 2025 recall figures. We definitely invite you to keep thinking about the deeper implications here. Thanks for joining us for this deep dive.